In section 2.2, let's look at piecewise functions. So remember, piecewise functions are just a function defined by two or more equations over a specified domain. Kind of like when we did absolute value of x, right? And we broke it up into two parts. So it's just piece by piece you're looking at it. So let's look at this example for f of x. Okay, it's got two different pieces to it. I notice the key parts over here. This is really what's specifying the domain. So I notice something's happening at 1 for both of those. Okay, we're transitioning from one picture to the other, or from one graph to the other, if you will. Okay, so let's talk about this in a couple of different ways. So first of all, here's what I do for the notation. I am going to, on the right-hand side, guys, I'm going to just sketch this with you. Now, I know this chapter is about graphing and being completely accurate, and when we're doing that, yes, that's required. So understand that these are just going to be sketches, but I want them to be pretty accurate sketches, okay? So let's talk about what the different pieces mean. Don't draw this yet, just kind of listen. If they're using this notation, it says to the right of 1, when x is to the bigger than 1, okay, so here's where x is 1, I'm going to draw whatever this is a picture of. And we're going to talk in a moment, but hopefully you're going to see that that's a parabola. So this is a complete sketch. Let's say I just had a general parabola drawn here. Well, this domain of x being greater than 1 says, well, I can't draw it at 1, so I've got to have something here, an open or a closed circle. And I'm only going to draw this part that's on the right. Okay? And that means, and like in Algebra 1, I think you then picked it up a lot of times and you just erased the other side. Okay? We just want you to think about it ahead of time so that you don't have to do a bunch of erasing. Okay, so that's really what the domain restriction does for you. Okay, so we're going to make that go away. And then, like I said, we want to do some pretty accurate sketching. So this will just help us practice for these types of problems. So here's what I'm going to do. I'm going to pick up this 1 and plug it into this equation. So when I plug in x equals 1, I get a y value of 3. So I know I'm going to do something specific at the ordered pair 1, 3. Likewise, I'm going to do the same thing down here. If I plug in 1, I'm going to get a y value of 4. So I know I'm going to do something specific at the ordered pair 1, 4. Okay, so here we go. Let's go with the top equation that I used for the red. It's a parabola. Y equals x squared plus 2 would be a parabola opening up, shifted up 2. Okay, so here we go. Notice it says x is less than or equal to 1. So since there is an equal sign there, I am going to go ahead and say at 1, 3, I'm going to use a closed circle because of the equal sign. So I'm going to go to 1, 3, closed circle, just because I happen to know it's a parabola that's shifted up 2, and the less than sign says only draw this to the left. Well, then that's a pretty good sketch of what I know about that parabola, because think about it being shifted up 2. Okay, so 0, 2 should be on that graph. All right, the bottom one then that we had done in blue, notice at 1, 4, so right here, there's no equal sign. So at 1, 4, I'm going to put a open circle. It's not defined. So 1, 4, I'm going to go with a big open circle. Again, that's a parabola opening up, shifted up 2. The y values are all multiplied by 2, so it's stretched vertically. Notice I can only draw the right side of that parabola. Okay, the right side of that parabola, because it says x is greater than 1. All right, so again, this is just a quick sketch. There we go. That would be a pretty accurate sketch of this piecewise function. Okay, and now let's talk about finding these different values. So if I asked you for f of -2, well, first thing you got to check is the domain. Would -2 fit in the top or the bottom equation? Look at the domain. -2 is less than 1, so you should be plugging this into the top function. You would be saying -2 squared plus 2. So f of -2 would be 6. All right, f of 1. Well, notice 1 is only defined for the top function, so you'd be plugging it into the top one. 1 squared plus 2 would give us 3. F of 2 would fit where? Well, 2 is greater than 1, so we should be plugging this into the bottom function. So we should be looking at 2 times 2 squared plus 2, which would give us 10. Okay. All right, let's do one more. Just practice. So notice it says graph. Again, this is going to be a sketch. In reality, graph means be completely accurate. I'm going to do a pretty accurate sketch. Okay, so in this chapter, yes, you are graphing, but let's just play around with this. Now, if you really needed to, guys, if you're understanding the notation, then hopefully you understand that if x is less than 3, you've got to use this function. Yeah, you could do an XYT chart. I'm going to go with what we already know in this. Okay, I just get rid of this so we don't have so many distracting things going on. And let's start graphing. Okay, let's just plot some points. So I notice, once again, that if I plug in 3 here, I would get 0. So I know at 3, 0, I'm going to do something specific with that ordered pair. If I plug 3 in here, I would get 0 again. Okay. All right, so graphing the top one. Well, here's what I'm going to do. I'm going to go to 3, 0 first. And at 3, 0, I am going to put an open circle because there's no equal sign. It's not defined there. Likewise, 9 minus x squared. You really should rewrite that as, for yourself, -x squared plus 9. So I hope you're thinking it's a parabola, opening, down, shifted, up 9. Okay. All right, so if it's a parabola opening down, shifted up 9, and I can only draw it to the left of x being 3, well, I know if it's shifted up 9 that it would go through this point. Okay, so again, guys, this is just going to be a sketch. But there would be that side. Okay, and now the next function in blue. Well, because of the equal sign, when I plug in 3 and get 0, go to 3, 0, and this one happens to now fill this open circle in. Okay, so now it's filled in at 3, 0. And y equals x minus 3, well, that's a line, right? You'd have a y-intercept of -3, a slope of up 1 over 1, up 1 over 1. If you quickly drew that whole line, you can see that it will go through this 3, 0 point. And again, if it's got the slope of up 1 over 1, and I can only draw it to the right of 3, well, there's a sketch then. That's the part of the line I can include. Okay, so kind of a weird looking graph, guys, but that's how you do piecewise functions. Just one piece at a time, analyzing what each of them looks like and what the domain is telling you. Good luck.